Imagine a fighter jet that can travel from New York to Los Angeles in under 10 minutes, a machine that thinks faster than any human pilot, an aircraft that becomes completely invisible to enemy radar while operating in space itself. Sound impossible? The Pentagon is already working on it. China has flying prototypes. Russia claims they'll have theirs by 2035. These aren't your grandfather's fighter jets. Weapons are now being designed that could make the F-35 and even the brand new F-47 look like relics. The 7th-generation fighter is coming, and it promises to redefine air warfare. The race for air superiority has entered a dramatic new phase. While most headlines focus on the F-35's challenges or Boeing's F-47 contract, military engineers worldwide are secretly developing something far more revolutionary. Technology that could make today's aircraft obsolete overnight. The F-35 Lightning, despite its troubled history, represents the peak of 5th-generation aviation. The F-47, awarded to Boeing in March 2025, is expected to be the first true 6th-generation fighter. But here's the issue. By the time the F-47 enters service, rival nations may already be testing 7th-generation systems. Think of it this way. The difference between a World War II fighter and an F-35 is massive. The gap between today's fighters and 7th-generation aircraft may be even greater. Current fighters like the F-22 can reach around Mach 2.2. That's fast, but 7th-generation designs aim for sustained hypersonic flight, above Mach 5 or more than 3,800 miles an hour. At that speed, an aircraft could cross the entire continental United States in under an hour. But speed is only the beginning. These machines will operate in ways that break from everything we've seen before. Where the F-35 introduced sensor fusion, 7th-generation fighters will employ quantum radar, able to detect stealth aircraft by exploiting the principles of quantum physics. In short, today's stealth technology may soon be obsolete. The most radical shift will come from artificial intelligence. Instead of simply executing pre-programmed commands, 7th-generation fighters will think, adapt, and make split-second decisions on their own. Their AI will learn from each mission, study enemy tactics, adjust strategies, and share that knowledge instantly across an entire fleet. Imagine a pilot with perfect memory, lightning reflexes, and the ability to process thousands of data points in real time. That's the level of performance envisioned. But the real breakthrough won't be in the individual aircraft. It's in how they work together. A single fighter could serve as the command hub for dozens or even hundreds of drones. These won't be simple remotely controlled units. They will be sophisticated platforms coordinating attacks with precision beyond human ability. One aircraft could command an entire airborne armada, overwhelming defenses through sheer numbers while staying out of danger. Of course, this vision requires materials and systems that don't yet exist. Flying at Mach 5 generates temperatures hot enough to melt steel. New materials, advanced ceramics, and metamaterials engineered at the molecular level will be needed to withstand such conditions. Some of these can even change properties in response to stress or repair themselves when damaged. China has already shown commitment to this path. Its White Emperor program demonstrates early concepts consistent with 7th-generation requirements. Photos from Chinese test facilities reveal designs flatter and broader than conventional jets, clearly optimized for hypersonic flight. Russia, despite setbacks in Ukraine, continues investing heavily. Its PAC-DP program aims to create fighters capable of operations in space. Yes, actual space-capable fighters. This is another defining leap. 7th-generation aircraft won't be confined to Earth's atmosphere. They'll be designed for dual roles, operating both in the air and in space. This opens entirely new tactical options. Imagine an aircraft that climbs to the edge of space, conducts surveillance across continents, and strikes targets anywhere on Earth within minutes. It might deploy tactical satellites, intercept enemy spacecraft, or conduct reconnaissance missions impossible for today's jets. Traditional missiles and guns will give way to directed energy weapons. High-powered lasers could destroy incoming missiles, disable enemy electronics, or hit targets with surgical precision. The challenge, as always, is power. Laser systems need enormous amounts of energy, far more than today's fighters can generate. Proposed solutions range from compact fusion reactors to revolutionary battery systems. Electronic warfare will also advance dramatically. These fighters will jam communications, disrupt radar, and even launch cyber attacks mid-flight. They could generate false radar signatures, making enemy forces chase phantoms. Stealth technology will evolve into full multispectral invisibility. Instead of focusing solely on radar, future fighters will conceal themselves from infrared sensors, acoustic detection, electromagnetic monitoring, and even the human eye. Adaptive camouflage could alter appearance in real time. Cooling systems would eliminate heat signatures. Sound damping systems could make them nearly silent. Advanced materials might scatter electromagnetic signals unpredictably, creating confusion in enemy detection systems. The way these fighters are built will also change. Instead of traditional assembly lines, production will rely on advanced 3D and 4D printing. Components could be printed on demand and even designed to change shape or function after production. Maintenance will become predictive. Aircraft will monitor their own condition continuously, forecast failures, and even carry out minor repairs automatically. Field crews may print replacement parts directly at the base, cutting downtime dramatically. If pilots remain part of the equation, their job will be completely different. Instead of directly flying the plane, they'll act as supervisors, making strategic decisions while AI handles tactical execution. Training will require knowledge of AI systems, quantum physics, and even space operations. Future fighters won't rely on vulnerable GPS. Instead, they'll use quantum navigation, drawing on fundamental properties of matter to calculate position anywhere: air, space, even underwater. Communications will be secured by quantum encryption, which, unlike current methods, cannot be intercepted without detection thanks to the laws of physics themselves. Most experts believe 7th-generation fighters won't enter service until the 2050s. The challenges are simply too immense to solve quickly. But breakthroughs in AI, quantum computing, and materials science could accelerate the timeline. The costs will be staggering. The F-35 program already exceeded $1 trillion. 7th-generation development could be several times that amount, requiring global cooperation. No single nation may be able to afford it alone. The implications go far beyond engineering. If one nation achieves a decisive advantage, it could destabilize international security, sparking new arms races or conflicts. There are also ethical dilemmas. Should machines be allowed to make life and death decisions without human oversight? Current doctrine requires humans to authorize lethal force, but future fighters may operate too fast for meaningful human input. International law is not prepared for this. Rules of engagement assume human decision-makers, not autonomous systems. Legal frameworks for such weapons remain hotly debated. 7th-generation programs may also prioritize sustainability. Propulsion systems could use hydrogen or biofuels, reducing emissions. Additive manufacturing could minimize waste. Modular designs might allow easier recycling of parts. Civilian industries could benefit from spin-offs. Advanced materials, propulsion systems, and manufacturing methods often find commercial uses. The space industry, medicine, and construction could all see breakthroughs originating in military labs, just as GPS and the internet did decades ago. Supporting these aircraft will demand specialized facilities, trained technicians, and highly secure supply chains. Nations may need to shift production to domestic factories to protect sensitive technologies. Cybersecurity will be critical. These advanced aircraft will be prime targets for hacking. Protecting their software and AI systems will require constant updates and vigilance. The psychological effect on opponents could be immense. Facing an enemy with overwhelming technological superiority has historically damaged morale. 7th-generation fighters could win battles simply by showing up. But overconfidence is dangerous. Technological advantages are never permanent. Training, doctrine, leadership, and logistics remain essential. Even the most advanced aircraft are useless without skilled operators and strong strategy. The United States has historically led in military aviation, from the P-51 Mustang in World War II to the F-35 today. Whether it maintains that lead depends on 7th-generation development. China's rapid modernization and heavy defense spending make it a serious challenger. Russia continues to innovate despite economic strain. Europe is pushing forward with programs like Tempest, while smaller nations may join partnerships to share costs and expertise. The road to 7th-generation fighters will be long, expensive, and uncertain, but the pursuit itself will drive innovation, shape geopolitics, and redefine air power. These aircraft aren't just the next step in military technology. They represent a transformation in how nations project force, defend themselves, and compete on the global stage. The race has already begun. The only question now is who will master this technology first, and what that will mean for the balance of power in the decades ahead.